Noir Plasma Chrome Bleed. Unlocking knowledge, inspiring innovation, empowering curious minds.
This website makes learning so easy. I found all my resources here.
Like what you share.
String theory suggests that the universe is not made of particles, but of tiny, vibrating strings of energy, harmonizing to create all reality.
Okay, let's dive right in. Today, we're setting our sights on the very edge of theoretical physics to look at two deeply fascinating frameworks born from string theory. We're talking about mind-bending concepts that challenge our traditional understanding of mathematics and the universe itself. If you love seeing how abstract ideas weave the very fabric of reality, you are in exactly the right place. Right out of the gate, I've got a question for you. How on earth do you study a physics theory that doesn't even have a known equation? I mean, it sounds like a total paradox, right? But believe it or not, this is the exact massive puzzle theoretical physicists face with our very first topic today. It's a theory we know should exist, but it absolutely refuses to be written down in the standard way. So here is our intellectual roadmap for this explainer. First, the 6D2,0 enigma. Then bridging physics and math, followed by the ABJM theory, and finally we'll tie it all together in the universal web. All right, part one, the 6D20 enigma. We're looking at the six-dimensional 2,0 superconformal field theory. This is a quantum field theory predicted by string theory, but here is the wild part. It is incredibly mysterious because it lacks what we call an action functional. Now, in physics, an action functional is basically your starting equation. So without it, you're literally trying to build a house without the architectural blueprints. And yet, despite that massive hurdle, it remains an absolutely crucial object of study. Because we can't study it the traditional way, physicists treat this 6D theory as a sort of master blueprint. You start with this six-dimensional framework, and then you compactify it. Basically, you fold it down onto a two-dimensional surface. Doing this spawns entirely new, mathematically fascinating lower-dimensional quantum field theories, like ones in 4 or 3 dimensions. It's kind of like casting a 3D shadow from a 4D object, except here we're scaling down from 6 dimensions. Mind-bending for sure. And this whole compactification trick, it led to a massive breakthrough. Theorists Luis Alday, Davide Gallardo, and Yuji Tachikawa discovered what's now known as the AGT correspondence. This is just a beautiful physical duality. It essentially shows that when you compactify down to a 4D theory, the physics of that new 4-dimensional theory perfectly relate back to the physical concepts of the original 2D surface you used to fold it. It's this elegant, perfect mirror reflecting different dimensions against one another. Moving right along to part 2, bridging physics and math. Now, what's really fascinating here is how one single theoretical physics framework acts as a sort of master key. The 6D2,0 theory isn't just for physicists. It has actually yielded incredible results in pure mathematics. Specifically, we're talking about the geometric Langlands correspondence, Kovanov homology, and hyperkähler geometry. It is incredibly rare for a physics concept, especially one without a basic equation, to unlock 3 completely distinct branches of math like this. To give you a concrete example of how this works, let's look at physicist Edward Witten. The geometric Langlands correspondence was this massive conjectural relationship in mathematics, basically a grand unifying theory of math that remained totally unresolved. Well, Witten brilliantly utilized the 6D2,0 to actually provide a physical explanation for it. He basically took the rules of a higher dimensional physics framework and used them to prove a point in pure abstract math. Just amazing. But wait, it gets better. Have you ever heard of Kavanagh homology? It's a mathematical tool developed by Mikhail Kavanagh right around the year 2000, and it's used in knot theory to study and classify the different shapes of knots. I know, it sounds super abstract, but it's actually a very rigid, pure mathematical classification system. Building right on that, Witten demonstrated that this exact same six-dimensional theory could actually be used to understand Kavanagh homology itself. Seriously, just think about that for a second. A predicted quantum field theory from string theory is being used to understand the intricate shapes of mathematical knots. The crossover between these disciplines is just absolutely staggering. And to wrap up the pure math applications, we have the phenomenal work of Davide Gallardo, Greg Moore, and Andrew Nietzsche. They used physical ideas directly stemming from the 6D20 theory to derive entirely new results in hyperkähler geometry, which, by the way, essentially deals with complex multidimensional shapes. So again, an equationless physics framework handed them the exact tools they needed to push geometric mathematics forward. Unbelievable. Okay, let's pivot a bit to part 3, the ABJM theory. Meet the ABJM theory. It's named for its 4 foundational researchers, Aharoni, Bergman, Jafras, and Maldacena. Now, this theory operates in a 3-dimensional superspace with something called n equals 6 supersymmetry. Okay, I know, that is a heavy dose of jargon right there, but stick with me because what this theory actually does is remarkable. What makes the ABJM theory so incredibly special is that it provides a holographic dual. A holographic dual is a really profound theoretical tool where a theory functioning in one space acts as a perfect mathematical mirror to a gravity theory in a higher dimension. In the case of ABJM, it provides a dual to M theory, which is a massive 11-dimensional framework on a very specific geometric space, known as ADS4 times S7. And this brilliantly illustrates something key. The ABJM theory doesn't just sit in isolation. It's closely related to Chern-Simons theory, which is a famous framework used to understand quantum states. It's a great reminder that in advanced physics, discovering one theory almost always illuminates several others that previously seemed completely distinct. But here is exactly why this matters to you. The ABJM theory isn't just high-level superspace math floating in the ether. It actually serves as a highly useful toy model for solving real-world problems in condensed matter physics. Meaning, physicists are taking this abstract 3D superspace theory and using it as a practical tool to understand the very complex behaviors of solid and liquid matter right here on Earth. Which brings us to part 4, the universal web. So, the crucial point is, when we look at the big picture, we see how different starting dimensions lead to vastly different, yet equally profound applications. On one hand, the 6D theory lacks an equation, but somehow unlocks the absolute deepest secrets of pure math, like knot theory. And then on the other hand, you have the 3D ABJM theory providing a holographic dual to gravity, which actually helps us solve tangible problems in condensed matter physics. Ultimately, what this explainer really highlights is that these frameworks forge unprecedented alliances between incredibly diverse branches of human knowledge. We're talking about building bridges between quantum field theory, string theory, pure geometry, and condensed matter. They are revealing this underlying, deeply unified mathematical structure to the universe. Which brings us to our final, provocative thought. If theories without standard action functionals can unlock the intricate shapes of mathematical knots, and holographic superspace models can explain the behavior of everyday condensed matter, what other invisible mathematical threads are currently holding our universe together, just waiting to be discovered? Thanks for exploring these incredible frameworks with me today. Keep questioning and keep learning.
Like what you share.
This website makes learning so easy. I found all my resources here.
Noir Plasma Chrome Bleed. Unlocking knowledge, inspiring innovation, empowering curious minds.